All right, we're going to take a look at some of the calculator section questions on the 8th grade math PARCC. So, the average distance from Earth to Moon is approximately, that is a really, really big number. That's 384,400,000 meters. What is the average distance in kilometers from Earth to the Moon? And write it in scientific notation. Now, the first thing I'm going to look for is exhibits. And it tells me that 1 kilometer, that doesn't tell me that, does it? You should know that 1 kilometer is equal, or 1 meter is equal to, or sorry, 1 kilometer, I keep on saying that. 1 kilometer is equal to 1,000 meters. So the first thing that we need to do is we need to take this number and we need to divide it by 1,000. So the easiest way to think about this is to think about it as a fraction. Division really is just fraction, right? So here's my 1,000. And so I can cross off the zeros. So we have 384,400 kilometers. So we've done our first conversion. So the next step is to convert this into scientific notation. Now to do that, we have our decimal point. And essentially, when we move the decimal place over one space, each time that's like multiplying by 10. So 10, this is 10 squared, 10 to the third, 10 to the fourth, 10 to the fifth. So we have 3.844 times 10 to the 5th power, because we moved the decimal place 5 times, and that would give me this answer. All right, moving on to the next problem. The number of bottles a machine fills is proportional. Now, when you see proportional, you know proportional means linear, so we should be looking at something that's in the form y equals mx plus b. I'm guessing b is going to be 0. So let's start over again. The number of bottles a machine fills is proportional to the number of minutes the machine operates, and that makes sense. The number of minutes is independent of how many bottles the machine fills. The machine fills 250 bottles every 20 minutes. That is a lot of bottles in a little bit of time. Create a graph that shows the number of bottles, y, the machine fills in x minutes. To graph a line, select 2 points on the coordinate plane, and the line will be drawn through the 2 points. So, let's take a look at this. You need help, Cody?
No, I just don't know where Miss Stoddard is.
Just hang out here till she sees her. All right, so the first thing is I need to find the slope. Now in PARCC they keep calling slope the constant of proportionality. Why don't they just call it slope? I don't know, but they don't. So if we have 250 bottles in 20 minutes, I'm going to pull up my calculator. Why? Because I can. So let's go ahead and divide 250 by 20. 250 divided by 20. And that gives me a grand total of 12.5 bottles per minute. It's important to know that's in per minute. So that means that my equation, not that I'm using it, not that I'm being asked for it, is y is equal to 12.5x. So how many bottles do I fill in 0 minutes? 0 bottles. So I'm going to go ahead and put a dot right here. Okay. Hey, Marina. Then let's take a look. Well, after 1 minute, I'm going to have 12.5 bottles. That's not great. After 2 minutes, I'll have 25 bottles. So after 2 minutes, I'll have 25 bottles, and there's my line. Graphing a line on PARCC is really, really easy and nice, isn't it? Henry's nodding his head. Yes. So I'm going to erase this and I'm going to move on. All right, next question. In a system of two linear equations, the lines represented by each equation have the same slope. So let's draw this out. It's always helpful to draw it out. What am I going to ask you to do when you get a problem? Draw it out. So I have a coordinate grid, and I have one line that has this slope. Then if I have a second line, let's say it has the same slope, I have two parallel lines. So are these lines ever going to cross? No. Well, if they don't cross, then I'm never going to have a solution. So it is safe to say that I will have no solutions. But I notice it also says select each correct answer. There may be another one. Is it possible that, going back to my original line, is it possible that my second line has the same slope and the same y-intercept? If that's the case, it's essentially like drawing two lines on top of each other. Well, how many times do these lines touch? And you can see by my visual, they touch all the way across the line. That means we have an infinite number of solutions. And in the box down here, it wants you to explain why you chose those two, A and E. And so you can talk about that two lines that have the same equation have this, that have the same slope are parallel, and parallel lines don't touch. And a solution is where two lines cross. And then you should also talk about, if you have two of the same line, that the lines will be drawn right on top of each other. Therefore, they will be touching at an infinite number of points. And so there are an infinite number of solutions. Just to go one step further, it would look something like this. Let's say I had 2x plus 3 is equal to 2x plus 3. They are the same line. If I were to go through and solve this, I get 2x is equal to 2x, and obviously you can say they're the same. Let's divide by 2, and I would get x is equal to x. And this is a true statement. This tells me that I will have an infinite number of solutions because the lines are the same. On the other hand, let's try this. If I have 2x plus 3 is equal to 2x, just say 2x. Let's go ahead and solve this. So they have the same slope, but a different y-intercept. This one's 0, obviously. So let's subtract 2x from both sides, get the x's together. I get 3 is equal to, well, 2x minus 2x is 0. This is a false statement. If I get a false statement, there's no, oh my goodness. Obviously, you see why I'm not a spelling teacher. If you get a false statement, then you know that the lines are parallel and they will not touch. Sorry for the long-winded explanation on that one, but I figured it would make sense. On problem number 4, two utility companies sell electricity in units of kilowatt hours. The cost of electricity for company P is shown in the table. Great. The cost of electricity for company M can be found using the equation shown. Well, of course, they give you an equation and a table, but not the same for both companies, where y is equal to the total cost in dollars and x is the kilowatt hours of electricity. Great. Use the information provided to find the unit rate in dollars per kilowatt hour for each company. Show your work and explain your answers. Okay, I'm not going to type it out. I'm going to explain it and sort of write things. Right now, I know company M has a unit rate, this is M, of 15 cents per kilowatt hour. And that is what the slope is, i.e. constant of proportionality. Now, the company P is a little trickier because they didn't just give us a slope or an equation. We have to go back and find it. So what is the difference between 198 and 150? Well, I just subtract them, right? And I get 48. So that's $48. And the difference in kilowatt hours that were used is roughly, I don't know, 400. So for me to find my constant of proportionality slope, I'm hoping if I say it enough that you'll get the idea. I'm going to have to divide my rise is right here, by my run. So if I have 48 divided by 40, I will get, that's not right, 400. I would get 12 cents. I'd move the decimal place over, but I will prove it, so I'll clear it. Obviously 1.2 makes no sense in the context of this problem. Divided by 400, which would have been the clue that I didn't type it in correctly. So that's 12 cents per minute, or sorry, per kilowatt hour. So in the space provided, you would have to first talk about the slope being the rate per kilowatt hour, and then you'd also have to talk about the slope here being the rate of kilowatt hour. You'd have to explain how you got that, saying the difference, the rise of your equation is 48, the run is 400, and 48 divided by 400 is 12 cents. So that would have a rate of 12 cents per kilowatt hour. So that's the first thing you have to talk about. Then find the total cost in dollars of buying 2,375 kilowatt hours of electricity from the least expensive company. That's company P. So the easiest thing to do on this problem is to create an equation. So if we have y is equal to my slope times x, my slope here is going to be 12 cents. So let's plug in 2,375 for x. So I have y is equal to 0.12 times 2,375. Let's multiply it out. Anytime now. Okay, that's really not what I wanted. It squared it. Isn't that kind of cool? So if I do 0.12 times 2,375, I will get $285. And so you would have to write out the equation that you have and then say that y is equal to $285. And that's what you're being expected to do in this problem. So I'll post the next 4 problems tomorrow. Oh, that's only problem 4. I'm going to do one more problem. Sorry for getting you all excited that I'd be done with this video. And that's still my pen. All right. Oh, I love this problem. Don't you love this problem? Henry loves the problem. So it tells us that explain why our triangle RTS is similar to triangle VTU. Okay. First things first. We need to talk about how to talk about angle measurements. If you put an M in front of the angle symbol, that means the measurement of. So the measurement of, and now we need to talk about angles. So angles are always referred to in 3-letter combinations, and the middle letter is going to be the point at which both your legs of your angle come together. So if I'm going to describe this angle here, I can say it is the measure of angle VTU, or I could have said angle of M, measure of angle UTV. And I can say that because the T is in the middle place. So I can say that the measure of angle VTU is equal to, or probably equals, angle, and let's go with this one, the measure of angle STR, because they are vertical angles. And vertical angles are just simply angles that are opposite each other when two lines have crossed. For instance, angle 1 and angle 2 are congruent because they are vertical angles. Angles 3 and angles 4 are congruent because they are, you guessed it, vertical angles. So that's the first thing I have to write. Second, there is a very well-known rule in geometry saying that when you have two parallel lines, and that parallel lines are cut by a transversal, that's what this is called, a transversal, that alternate, so see how one's below and one's above, alternate interior angles are congruent. So I can say the measure of angle TVU is equal to the measure of angle TRS because they are alternate interior angles. Likewise, I can say that the measure of angle TSR equals the measure of angle VUT because they are alternate interior angles. Well, if you have two shapes that share the exact same angle measurements, you know they're similar. And there you have it. The next problem. Wait. Well, come on. And it wants to quit. That would be really unfortunate. This is why you should never be impatient, folks. All right, so now we're back. Excellent. The problem says that the measure of angle STV is 180 degrees. Or sorry, 108 degrees. Well, that means this angle here has to be 72 degrees because this whole angle obviously adds that they're complementary angles, which means they're equal to 180, so 180 minus 108 is 72. That means this plus this is going to be equal to 180 minus 72. Well, we already learned that's 108. And I understand that they're looking at angle SRT, but angle SRT, we've already said, is the same as angle TVU, because they are alternate interior angles. So therefore, the measure of these two angles are 108 degrees.